So this is problem number 8, and we've basically got a velocity versus time graph. Okay. Now, we had kinematics equations that tell us v equals at plus v naught. And if you look at this, this is another y equals mx plus b type equation. So we can graph it and we get a line. Now, the initial velocity of the object is the velocity at time equals 0. So that tells us that v naught is 3 meters per second. And just as any y equals mx plus b equation goes, if we want to get the acceleration, that's this number here, and we realize that's actually the slope. So to get the acceleration, I'm going to do a rise over run calculation. And in fact, let me just get rid of this guy so I can do that rise over run. So I'll take this guy here and this guy here. The point here is 0, 3, and up here it's 8, 7 for my points. So when I go ahead and get the acceleration, that's going to be 7 minus 3 over 8 minus 0. And that's giving me an acceleration of 1/2. And if I want to get units on there, that's meters per second squared. Okay. Now for part C, they say use the information from A and B to get me the displacement. So using the information from the graph that we calculated, what we're going to do is we're going to go ahead and we're going to plug these numbers into our kinematics equation to get the displacement. So x equals 1/2 at squared plus v naught t plus x naught. And when we plug in our numbers, that's going to end up being 1/2 times 1/2 times 8 squared plus 3 times 8. And when we plus 0, and when we actually calculate that out, we're going to end up getting x equals 40 meters. So again, the A is 1/2, and I'm plugging that into here. And the initial speed, or the initial velocity is 3, which I'm getting from part A. So I'm plugging that into there to get 40 meters. All right, then for the next part, they say, what does the area under the velocity versus time graph tell you? I called it a curve. That was me being mathy. I should have just said graph. So let me just move this here. So let's just get that area. And we're going to split this into 2 pieces. So here is a rectangle, and it's got a width of 8 and a height of 3. So the area of the rectangle is 24. And then we have this triangle here. It's got a height of 4, and it's got a base of 8. So when I get the area of the triangle, that actually works out to be 1/2 base times height, which is 1/2 times 8 times 4, and that works out to be 16. So when I get the total area, the rectangle plus the triangle works out to be 24 plus 16, which equals 40. This actually goes back to our first exam. It's actually the last multiple choice question where you get the area under this rectangle and it ends up being -16. So what this tells us is, just like the buggy lab, the area under v versus t equals the displacement.